Hi, my name's Tian and this video is on my cloud application, Shared.world. So the purpose of this application was to promote responsible travel and to help prevent overtourism. There are three main goals that this application has to try and achieve this purpose. The first is to educate travelers by having a one-stop shop of travel blogs. The second is to list posts that match the user's interests so that they're actually looking at information that's relevant to them and not just the most popular. And the third was to have an informative map to help travelers make decisions based on places that perhaps need more visitors. So how is this going to be achieved? So the basic architecture of Shared.world is split into four main sections: software, computing, storage, and big data. So to start off with, the backend of the project was written in Django, which creates views and models for other applications to be able to use. The models essentially become the tables for the database, and the views can be read by other applications via RESTful API. So the React was used for the front end of the application and was able to take the views from Django and dynamically display them out. The third piece of software was the Google Maps API to show that informative map that I spoke of. So when it came to deploying the project, I did have a little bit of issue with trying to have the two serve together. So instead I opted to keep the two separate, and due to their API nature, this was possible. And actually on deployment, it was much more efficient than when running locally. So for the backend Django application, I decided to deploy it onto App Engine, which by default creates two VM instances. So when an application is deployed onto App Engine, it is put into a Docker container and then deployed there. For React, I decided to use Google's Firebase, as this is designed specifically for front-end applications. And these two can communicate very easily via the web URLs that the two are given. When it came to the storage of the application, I decided to stick with the relational database due to the very structured nature of the data that was being received by users. So Django typically is best companioned with PostgreSQL. So I decided to use that on the CloudSQL platform, and fortunately it is supported to have read replicas and high availability to replicate that of a cluster environment such as MySQL cluster to create that distributed storage environment. For all the media files such as images, etc., I decided to use cloud storage over a distributed file system, as it's much more efficient for an application of this nature or running on the same platform. So all of the data files were stored there. When it came to the big data side of the application, I decided to stick with the GCP platform. So I ran all my programs off of the Dataproc cluster for Apache Spark. So in order to output the posts based on the order, I wrote a program in IntelliJ using Scala and stored that information, stored those jar files onto cloud storage, which could then be read by Dataproc to submit the jobs. And those outputs were then put back as JSON files into cloud storage, which could essentially be read by React. Also for the data analysis, I have a Zeppelin Notebook running. It does some basic analysis such as top interests for countries and users, which is also running on the Dataproc cluster, and that one is also written in Scala on Apache Spark. The final part of the whole architecture was that I was able to successfully create a linear regression model using the machine learning library of Apache Spark in a Jupyter Notebook using pyspark, which I'll be able to demonstrate shortly. The information for this model was taken in from BigQuery analysis of data from the World Bank indicator dataset. That information was read directly into Jupyter, onto Spark to run onto the Dataproc cluster and read out those results. BigQuery was also used to get the tourism and population from that same World Bank dataset that could be read by the Google Maps API to be displayed back into React. So that's the basic architecture of the whole system. Also CloudSQL could be read in by JDBC to Dataproc as well. So as you can see, everything is clearly connected. So now to demonstrate the project, so we have the GCP platform here where everything is running. So we've got the React front end running here on Firebase, and then the Django backend here on App Engine with two VM instances running. We then have our SQL database with high availability and read replicas. So for the database, the basic structure is mapped here. So we have a user, a profile, a post, an interest, and a country. The main things to note is that a profile must exist with the user ID. A post can only exist with the author as a profile, must have an interest and a country. And this ternary relationship here between profile, post, and interest. So essentially within the database, the table is going to look like this. So the main things to point out is that user ID is a foreign key to the ID of a user. The author is relating to the profile ID, the country to the country ID. We have the tagged, which has the tag ID relating to the ID of the interest, an object ID which relates to the profile or post ID, and a type here which determines which of the two it is. The other aspect is of the storage is where all the media files, etc. are stored. So here we have 3 buckets with Dataproc, media, and SAG to try and keep those nice and separated. And then for the big data, we have everything running on a Dataproc cluster, which is just running here. So on this cluster, we have a Jupyter and Zeppelin Notebook running, which I'll just run through very briefly. So this is the Zeppelin Notebook here. Essentially, we're just setting everything up to read from the database and just making a couple of small analysis. So the first one is to list the countries in order of posts. So the country with the most posts is listed at the top. We have the top interest by post, so we can see that the most popular interest for a post is party with 7 posts. And then we have top interest by users. So in fact, users are most looking for destinations that have the outdoors. And then we also have top interest for a chosen country. So for this, I've just chosen Australia. So we can see that the most popular interest in Australia is hiking for posts. So then we're also running a Jupyter Lab notebook for the machine learning aspect of the project as well. So using linear regression, basically, first of all, setting up a vector for these different factors, which are actually coming from BigQuery here. So these are some views that have been generated from the World Bank dataset, and a table here called regression input, which is basically a compilation of all of those views, which is being read into the Jupyter Lab notebook just here. And that's being read in as a Panda data frame and then converted to an SQL data frame so that we can do an RDD mapping from that previous vector to create a data frame that can be trained. So there's 2 linear regression models here. So the first one is just with a training model to get the coefficients, intercept, and the R-squared, which you can see here is quite high, which is good. And then the second training model here is using training and testing to output the prediction for the arrivals in thousands. So we can see here that they're actually quite close, being their actual answer and the predicted answer. The other aspect of the Spark programming will be demonstrated in just a moment. So when users first come to the application, they're brought to this login and sign up screen here. So I'm just going to log in with a predefined user that I've made. And we're brought here to this interactive map colored based on the tourist to resident ratio. So that is the percentage of tourists to residents. So we can see here that Iceland has the most of 648%. We have an about page that explains the app. And then here we have a list of all of the profiles of the users that are currently on the database. And this is the one we're logged in here. And we can see a logout button as well. So if we go back to the start here and we're going to select Australia and click search, we can see that there's no data, and that's because we haven't yet run the Spark program to generate the JSON files to display. So we're going to go back in and submit a job on the Dataproc cluster. So I've got all this set up here, getting the jar file from cloud storage, the driver, and the user ID is user ID 23. So we're just going to submit that one so that it can run in the background. Okay, so while that job's running, I'm just going to explain the code very briefly. So the code was written in IntelliJ and tested on Databricks. Essentially, there's 2 versions, one that iterates over every user and one that iterates over a single user, taking in the user ID as the argument. So basically, with this, we're just running through and connecting to the database, reading through the relevant tables and filtering them as necessary, and then iterating over every single country to match the country ID to get the interest for the users, the interest for the posts, selecting those together for the ones that actually match, and then grouping them and sorting them with the post with the most matches first. This is then getting written out as a single JSON file with these relevant folders here, and this here is to make it one file. So if we head back to Dataproc, we can see that that job is finished, and if we go to the bucket, we can see that there's now a folder here for user 23, and that's created a JSON file just here with the post with the most matches listed up first. So if we head back to the app and back to the start page and now select Australia and search, we can see that it's now come up with a list of posts. So this particular user is interested in camping, beach, hiking and outdoors. So this first one here, we can see has 3 matches. And if we just go back and go to Australia again, we can see that the one down here, in fact, only has 1 match. So it has ordered them. On this page, you can also click on the author of the profile and see a list of the posts that they have written there. And that's my application.